right, this will be the 2010 AMC 10A, problem 21. The polynomial x cubed minus ax squared plus bx minus 2010 has three positive integer zeros. What is the smallest possible value of a? This a right here. We have to understand some terms. What are the zeros? They're solutions to the equation x cubed minus ax squared plus bx minus 2010 equals 0. That's why they're called zeros, because they're values of x that make this true. Also called solutions or roots, or even x-intercepts if you're talking about the graph. What is the smallest possible value of a? So we need to know, again, three positive integer. They have to be positive integer zeros. So we know then that this needs to take on the form x minus r1 times x minus r2 times x minus r3. And we know that the product of the roots is going to equal negative 2010. Okay, so if they're all integers, then we can prime factor 2010. 201 times 10 is where I started. This is a multiple of 3, specifically 3 times 67, and this is 2 times 5. So our roots, there needs to be 2 out of these 4 numbers that are roots straight up. It just automatically roots, and the other one will be the product of the 2 numbers. So for example, we could do 3 times 5 is 15 times 2 times 67, and the roots would be 15, 2, and 67, 15 being the product of 3 and 5. So how are we going to get the smallest possible value of a? You need to know Vieta's formulas. Whenever you watch solutions, use them as a springboard for exploration, to look into different topics that you want to know more about. Vieta's formulas apply to polynomials. For example, for ax squared plus bx plus c equals 0, they teach us that the sum of the roots, which you could call r1 and r2 because this will have 2 roots, is equal to negative b over a. And r1 times r2, otherwise called the product of the roots, is c over a. Many people know these two as they teach them in your middle school or high school. It's more rare to know how that they also apply to larger polynomials. In fact, they do, and for cubics though, if I do ax cubed plus bx squared plus cx plus d equals 0, now the sum of the roots is still equal to negative b over a. You shouldn't memorize the letters, you should memorize their positions. This is the second coefficient and the leading coefficient. So it's the negative ratio of the second coefficient over the first coefficient. That way, if a problem uses different variables, it doesn't throw you off, because you understand conceptually it's the second over the first, the negative version of that. Same thing here. So in addition, the product of the roots, rather than being the last constant or last value over the leading coefficient, it will be it'll be negative d over a. So r1 times r2 times r3 equals negative d over a. And what happens as you go up in higher powers, like 4th degree polynomials, this will always hold true, that the sum of the roots will be the negative second over the first coefficient. But the product of the roots will alternate signs. So it's positive here, it'll be negative here. In the 4th degree, it'll be positive again. Okay, so this is a lot of information. I'm just summarizing information that you can learn elsewhere. I might do a video on Vietas in the future, but I think there's already enough content out there for that if you look it up. So how do we apply it here? Well, then the sum of the roots, r1, r2, and r3, is going to be equal to the negative second coefficient over the first, which is simply a over 1, or just a. So we're basically looking for the smallest possible sum of the roots. Well, if we don't use 67 straight up and we combine it with something like 2, for instance, it's going to be 134. That's not going to give you the smallest possible value sum. So we'd like to keep 67 as one of the 3 roots, one of r1, r2, or r3. Then what about the 3, 2, and 5? Which one should we combine? You can do some trial and error, but it's probably pretty logical that if you combine 3 and 2 to make 6, and you'll have 67 times 6 times 5, the sum of these two is only 11. If you look at the previous example I gave where we combine the 3 and 5, 15 is already more than 11. And if you do 2 times 5 is 10 plus 3, you'll get 13, which is still more than 11. So 11 is going to be the smallest sum of the other two roots, and so 11 plus 67 does give 78, the smallest possible sum of the roots.